All right, last lesson of this semester. Last lesson of this unit, 4.4, volume and surface area. Okay, so volume, we measure volume of a three-dimensional figure in cubic units. This is if we were going to be filling up a three-dimensional figure, okay, with liquid, whatever. All right, so surface area is, we will still measure surface area in square units. So surface area, remember, is like if I wanted to wrap the thing. Okay, I'd wrap it in paper. So the first shape we're going to look at is a cube, and the volume of a cube is length times width times height. Okay, so surface area is easy to find. Find the area of the top and the bottom, area of the front and the back, and the area of the two sides. And then you're going to add all of that up. Okay. Alrighty. So, if you wanted an actual formula for volume and surface area, so surface area has a length L, a width W, and a height H. The volume is length times width times height. Surface area is 2 times width plus 2 times width times height plus 2 times width times height. Okay, so let's look at this quiz yourself over here to the side. It says find the volume and surface area of a regular solid with length 8, width 6, and height 3. And we're looking in terms of centimeters. So let's do surface area first. So we're going to do 2 times 8 times 6 plus 2 times 8 times 3 plus 2 times 6 times 3. So this will be 96 plus 48 plus 36. So the surface area is 180 square centimeters. All right, the volume is simply 8 times 6 times 3, which is 144 cubic centimeters. Okay, not too bad. Now, if you have an object has a flat top and base and the sides are perpendicular, okay, so if an object has a flat top and base and the sides are perpendicular to the base, then you can find the volume by finding the area of the base and multiplying it by the height. Okay, so let's take a look at this one right here. We're going to call this A, and we'll call this one over here B. Okay, so I'm going to take my pencil, and this is the shape of our base, because whatever the shape of the base is here, that's the bottom too. Okay, and this is going to be my base here. So we're going to find that base first. So A, this is a trapezoid. So remember, we do 1/2 of base 1 plus base 2 times the height. So that's going to be 1/2 of 14 times 3, and that's going to be 21 inches. Okay, so now that we did that, we can do area times height. So the area of the base is 21. The height of the whole figure is 4. Okay, this height is the height of figure. Okay, so 21 times 4 is 84 cubic inches. All right, now this is the area of a triangle. Okay, and we know all three sides of the triangle, so we're going to have to use Heron's formula because we don't know the height of this triangle. Heron's formula. So what we're going to do is we'll do S equals 1/2 of 9 plus 9 plus 6. So that's 1/2 of 24, which is 12. So the area equals the square root of 12. Then you do 12 minus 9, 12 minus 9, 12 minus 6. Okay, so we have 12, and we have 3, 3, 6. Okay, so this is going to give me the square root of 648. Okay, I multiplied those four numbers together. So that area is 25.46 inches. So now do the area times the height. So this is 25.46 times the height of the figure is 3. So this is going to give me 76.38 cubic inches. Okay. The next shape we're going to look at. Oh, this is 2 blocks of cheese that are selling for the same price. Which block contains the greater volume? Okay, so we need to answer that question. A contains the greater volume. All right, cylinders. Now, cylinders, remember the base is a circle. So if we're doing the area of a base times the height, like we did up here, that's going to be pi r squared h. That's the volume of a cylinder. Okay, so all of these are area of the bases times the height. Okay, so for surface area of a cylinder, imagine that we take the bottoms off of the can and just unroll the side. Because then we would have a rectangle and with length 2 pi r and a height h. Therefore, the surface area of the side is 2 pi r h. Then the top and the bottom, the areas are pi r squared, and there's 2 of those. So that allows us to get our surface area formula. So surface area formula for a cylinder is 2 pi r h plus 2 pi r squared. And volume is pi r squared h. Okay. Now, it says a Pearl Art Supply store sells solvent in a cylindrical can that has a diameter of 4 inches and a height of 6. The giant economy size can of the same solvent has the diameter twice as large. The height of the can is the same and costs 3 times as much as the small can. Which can is the better deal? Then we're going to compare the surface area. So here we're comparing volumes. Okay, so here we're going to compare volumes. Okay, volume is pi r squared h. So let's go small can first. Okay, so the small can has a diameter of 4 inches and a height of 6. Well, we only need radius. So radius is half the diameter. So the radius here is 2 inches. So we're going to do volume equals pi times 2 squared times 6. And that's 75.40 cubic inches. Okay, let's look at the large. This time the diameter is 8 inches, so that means our radius is 4. And it says, because it says the diameter is twice as much, okay, but the height is the same. So the height is still 6 inches. So volume is pi times 4 squared times 6. And that's 301.59. Okay. Now, how much more is in the large can than the small can? It costs 3 times as much. So we need it to be at least 3 times as much as this one for it to be a good deal. Okay, for it to be unit price. Okay, so we're going to compare size. So we're going to do 301.59 divided by 75.40. And that gives me 4.00. So what this means is there are 4 times as much solvent for 3 times the price. So the large, you can't see that, I'm sorry. So the large can is the better deal. All right. Now, let's come over here and we're going to compare our surface area. Remember, our surface area is 2 pi RH plus 2 pi r squared. So let's do the small can. Remember, our radius is 2. Our height is 6. So we have 2 times pi times 2 times 6 plus 2 times pi times 2 squared. Okay, so this is 24 pi plus 8 pi. That's 32 pi, which ends up being 100.53 square inches. Now let's look at the large. The radius is 4. The height is 6. So 2 times pi times 4 times 6, which gives me 48 pi, plus 2 times pi times 4 squared, which gives me 32 pi. Add those together, that's 80 pi, which is 251.33 square inches. Oops, and I left off here cubic inches. Right there. Okay, now we need to compare size. So we take the big one, 251.33, and divide it by the small one, 100.53, and that's 2.5. So here, the large can is 2.5 times bigger than the small can. So they made it economically sized, but holds 4 times as much. Okay. The reason they make it smaller is it's cheaper for them to ship it and get it places than making the can 4 times its size. And 2, people don't want to have something great big and bulky in their cabinets. So volume and surface area of a right circular cylinder with a radius of 5 and a height of 10. So let's do surface area first. 2 times pi times 5 times 10 plus 2 times pi times 5 squared. Now that's going to be 100 pi plus 50 pi, which gives me 150 pi, which is 471.24 cubic square centimeters, excuse me. That's surface area. Volume, 2 pi r squared h. Not 2, excuse me, pi r squared h. I got a little mixed up there for a second, combining my formulas. Pi r squared h. So pi times 5 squared times 10. That's 250 pi, which is 785.40 cubic centimeters. Okay. And just like we talked about, an efficient container has a smaller surface area to volume ratio. There should be more volume, less surface area. Okay. All right. What are the dimensions of a can that will contain 1 cubic foot of liquid that will have the smallest amount of surface area? Okay. So, they told us here that our volume is 1 cubic foot. We know we're dealing with volume, so step 1, we know that volume is pi r squared h. And we know that the volume is 1. Okay, so the first thing we need to do is we need to solve for one of the pieces. Okay, we're going to solve for h. Get h by itself. So these are being multiplied, so to get them to move, you divide them. Okay, so now we come over in step 2, we look at our surface area formula, 2 pi RH plus 2 pi r squared. Now, we're going to plug in this value for h. So 2 pi r times 1 over pi r squared. And what you're going to see is when you multiply this, this pi cancels, and one of these r's cancel with that r. So this leaves me 2 over r plus 2 pi r squared. Now, step 3. Oops, I don't want to do that. I want to use blue for step 3. Now we're going to use our calculator. Okay? We're going to use the y equal button on your calculator. You're going to type in 2 over x, remember you use parentheses here, plus 2 pi x squared. And then you're going to press the table button. On your calculator. Then we're going to look for where the y value, and if you're thinking about it, if this is what you typed in, then y took the place of s. So this is your surface area. Okay, so where your surface area goes from big changes to just a decimal increase. Okay, and I want to put a hint right here. Set your table change to be 0.1. Okay, and what you're going to see when you type that in, so when we go to y equals, and we type in 2 over x plus 2 pi x squared, and we go to table, look at your table set, we want the table change to be 0.1, so we went to table set, so go to table, and where you're going to see it go from big changes to just a decimal change is right here, between 0.5 and 0.6. Okay, so that happens between 0.5 and 0.6. So 0.5 is 5.5708. 0.6 is 5.5953. So your ideal radius is between 0.5 and 0.6. Well, halfway between 0.5 and 0.6 is 0.55. Okay? We're going to plug this in to the height formula. From step 1. Okay, so when we plug that in, 1 over pi times 0.55 squared equals h. And that's going to give me 1.05, excuse me. So that means our radius is 0.55 and our height is 1.05. And that's the dimensions of the can. Okay, so we kind of had to work backwards. All right, now let's move on to cones and spheres. Okay, and if you need to rewind that, feel free to do so. All right, so the volume and surface area of a cone. Because a cone is 1/3 of a cylinder, because you're cutting out this and this, which are also parts, your formula is 1/3 pi r squared h. Your surface area is pi r times the square root of r squared plus h squared. Okay? Because in the formula for surface area of a cone, if we want to include the area of the base, we must add the pi r squared. Okay? But that's the formula we're going to use. Alrighty, here we go. So example 4. What's the volume and surface area of a cone with a height of 10 meters and a radius of 8? Alright, so surface area is pi r square root r squared plus h squared. So this is pi times 8. Then we're going to do under the square root 8 squared plus 10 squared. So this is 8 pi. This is 64 plus 100. And we have 8 pi times the square root of 164. You can type all that in at one time, and that gives you 321.86 square meters. Okay, so that's your surface area. Now your volume is 1/3 pi r squared h. So we have 1/3 times pi times 8 squared times 10. So we have 1/3 times pi times 64 times 10. Type all that in at one time, and you get 670.21 meters cubed. Okay, we can do this one for another practice problem. Find the volume and surface area with a radius of 4 yards and a height of 5 yards. So surface area is pi times 4 square root 4 squared plus 5 squared. So this is 4 pi square root of 16 plus 25. So that's going to be 4 pi times the square root of 41. You can type all that in at one time, and that's 80.46 square yards. And that's your surface area. your volume, 1/3 pi r squared h. So 1/3 times pi times 4 squared times 5. Type all that in at one time, and you get 83.78 cubic yards. Cubic yards. All right. Moving on. This one's a long lesson. Sorry, guys. Many northern states stockpile salt to use for melting road ice. In one such state, the highway department builds sheds in the shape of right circular cones to store the salt. Current sheds have a diameter of 30 feet and a height of 10 feet. The department plans to build larger conical sheds that will hold more salt. The larger shed will either have a 10-foot longer diameter, and it says either, and the same height, or the same diameter and a 10-foot greater height. So there's 3 types of sheds we're looking at here. Okay, so calculate the volume for each of the proposed sheds. All right, so let's do the blue first. So volume is 1/3 pi r squared h. So if it's a 10-foot longer diameter, that's 40 feet. So the radius would be 20 and the height would be 10. So that'd be 1/3 times pi times 4,000. Type that all in, and you get 4188.79 feet cubed. This is shed 1. Okay, let's do shed 2. So the same diameter, so the radius would be 15. Here the height would be 10 foot higher, so the height would be 20. So we would do 1/3 times pi times 15 squared times 20. So this is 1/3 times pi times 225 times 20. Okay, so that's 4,500. So 1/3 times pi times 4,500 would give me 4712.39 cubic feet. Okay, so that's shed 2. Calculate the surface area, okay, for each of the proposed sheds. So let's come down here. Let's do part B. Shed 1. Remember, surface area is pi r square root r squared plus h squared. Shed 1, r is 20, h is 10. So this is pi times 20 times the square root of 20 squared plus 10 squared. So this is 20 pi, and that's 400. That's 100, so this would be 500. Type that in all at once, and that gives me 1404.96 square feet. Shed 2. The radius is 15. The height is 20. So pi times 15 times the square root 15 squared plus 20 squared. Okay, so that's 15 pi. That's 225. That's 400. So that's 625. Work that out, and that's 1178.10 square feet. Okay, which design seems more economical? Well, this one's going to be a smaller shed, so it costs less to build, but it holds more. So shed 2 is more economical. You can write that here. Shed 2 is a better deal because it will cost less to build. And we'll put here smaller surface area. But will hold more. Bigger volume. Okay, so all I had to do was find volume and surface area for two things and compare them. That was all I had to do there. Okay, so let's go to the back, which is the last thing, which is a sphere. All right, so looking at the volume and surface area of a sphere, volume is 4/3 pi r cubed. Okay, 4/3 pi r cubed. And surface area is 4 pi r squared. Okay, Metrodelphia is replacing existing spherical water tanks with larger spherical water tanks. The Water Commission insists that to provide for the future expansion of the city, the new capacity of the tanks should be at least 5 times the capacity of the old. If the city purchased tanks that have a radius that is twice the radius of the old tanks, will these tanks satisfy the Water Commission? So what you need to do is just pick a number for a radius and double it and see if that gives you a number that's 5 times the old tank's volume. Okay, so I need to pick a number for R of original tank. So just to make it easy, R is 10. Okay, so we're going to go and do the old tank volume first. So volume is 4/3 pi r cubed. So this is 4/3 times pi times 10 cubed. So this is 4/3 times pi times 1000. When you type that in, you get 4188.79 cubic units, whatever that is. That's the volume of the old tank. All right, let's look at the new tank. So it says the radius is twice, so now the radius is 20. So we do 4/3 pi times 20 cubed. And that's going to be 20 cubed is 8,000. Sorry, that 8 looks so bad. 8,000. Type that in, and you get 33,510.32 cubic units. Now, I need to know if this is 5 times as much, so what do? I divide, okay? So what I'm going to do here is I'm going to take the new volume and divide it by the old volume. And I need it to be 5 times more, at least 5 times more. So 33,510.32 divided by 418879. When I divide that, it gives me 8 and change. So this is 8 times larger. Needed to be at least 5 times larger. So yes, they will be happy. Okay, we're going to do this last problem right over here. We're going to find the volume of a sphere with a radius of 6 centimeters. So we do 4/3 times pi times r cubed. So we have 4/3 times pi times 6 cubed. Okay, so 6 cubed is 216. So multiply those things together. Remember, when you're using a fraction, you can put it in parentheses. That'll help a lot. Okay, so this is 904.78 cubic centimeters. Okay, and that's it. We were just doing basic calculations with surface area and volume. If you have any questions, please let me know. Thanks, guys. Have a great day.